We have two methods for multiplying polynomials. One is the distributive property and the other is the box method. When we are using the distributive property with something other than a monomial out front, we distribute all of the terms in the first polynomial. So x needs to be distributed to x times x times 3, as well as 4 times x plus 4 times 3. So we're distributing all of the terms in the first polynomial to all of the terms in the second. So distribute and distribute. That gives us x squared plus 3x plus 4x plus 12. And then we just need to combine like terms. For a binomial times a binomial, the distributive property is a really efficient, great method. When we get to trinomials and larger, the box method helps us to organize our work. So multiplying together two polynomials, we could think of this as finding the area of a box with a dimension x plus 4 as well as a dimension of x plus 3. And we can find the area of each segment of that box just multiplying together the terms. X times x is x squared, x times 3 is 3x, 4 times x is 4x, and then 4 times 3 is 12. You can see that you do the same computation and get the same work that we got with the distributive property. Our work is just a little more nicely organized, and we make sure we don't forget to distribute any of the terms to any of the terms in the second polynomial. It's okay with me if you do this addition or combining of like terms in your head. So same answer, x squared plus 7x plus 12, and different work. When we have a trinomial times a binomial, a lot of students like to rewrite it. Multiplication is commutative, so they like to write it with the binomial as the first factor. That's fine. That allows us to do arrows on top, arrows on bottom. So x to the third plus 2x squared minus x plus 5x squared. How are you going to fit this? Plus 10x minus 5. Combining like terms, we just have one cubic term, two quadratic, two linear, minus 5. So that is my final, that's my final simplified answer. That's the product. Here, I guess I already rewrote that multiplication problem as x plus 5 times x squared plus 2x minus 1. With the box, it doesn't really matter so much, but one dimension is x plus 5, the other is x squared plus 2x minus 1. And we're just going to go ahead and multiply together each of those segments, finding the area of each area of the box. 5x squared, 10x, negative 5. Noticing here are our like terms. This simplifies to x to the third power plus 7x squared plus 9x minus 5. Fortunately, our answers match.